So in today's lesson, we're going to talk about the interference of waves. And so let's think about the word interference and what our common understanding is. Usually we think about somebody getting into our business, right? And so when two waves meet, then they tend to kind of interfere with each other. And so you can see here in this animation that we have two waves approaching each other. In the background, you can sort of see red and blue dotted lines. That's sort of showing you what each wave individually is doing, even though they are coming together to create a new wave that's a combination of both of the previous ones. So today that is what we're going to talk about, ways that waves can interfere with each other. So today there are two types of interference that we're going to talk about. The first is constructive interference. And so that's the type of interference where things are going to build on each other. Think construction, usually building something. And so I'm going to show you the case where we have wave A and then wave B here, and they're interfering. We can see that the arrows are showing they're approaching each other. And so we know that we have a crest meeting another crest, and this could just as easily have been a trough meeting another trough. We can see that the height of the resulting wave seems to be the sum of both of the heights of the amplitudes of those individual waves, right? And so then they go about their business and they move on after the interference, right? And so what gets created as a result of a crest meeting a crest is a supercrest. And if we end up with a trough meeting a trough, we end up with a super trough. So I liked this animation because the size of the waves, the amplitude of the waves that are approaching each other are different. So you can kind of see how they move past each other. So these waves are not just like bumping into each other and bouncing off. They're actually going over one another and continuing on their path. And so if the waves aren't interfering in a productive and a constructive way, they're going to interfere in a destructive way. And so that means that essentially the amplitude of one crest is going to be counteracting the effect of the amplitude of another trough. And so here we see wave A, which is a crest, approaching wave B, which in this case happens to be a trough. And they're approaching each other, and because they have the same amplitude, then we see that they interfere and completely destroy each other, and then we see them kind of moving on their way after the interference. This is called complete destructive interference. So when both waves sort of annihilate each other, then what you have is a situation of complete destructive interference. But it doesn't have to be necessarily complete. It can be partial and so on and so forth, as you probably saw yesterday in our hands-on lab. And so I really liked this animation because on top you can see what the waves individually sort of look like when they pass each other. And then on the bottom, the animation is showing how they kind of pass over each other and combine, and essentially like we see destructive interference, complete destructive interference at one point where the wave seems like it's not there anymore. And this brings us to this principle of superposition. When two things are superimposed, we can kind of decide to evaluate what the result will be when they're combined. And so we look at the algebraic sum of the displacements of the waves, right? And so those amplitudes. So here we can sort of see, if I can do it, we can see that, you know, this red wave is about 1 block high, right? 1 measurement high, whereas this trough here is, and we can see that the trough is 2 squares down, tall, I guess, deep, if you will. And so over here we can see, well, what happens when they are interfering with each other? Well, if we think of this as, you know, I have 1 step up and with the red wave and 2 steps down with the blue wave, right? I know that +1 minus 2 will land me at -1. Right? That makes sense. So again, +1 and then -2 for the blue wave. So +1 minus 2 will give me -1 overall. And so that's where I can show that they are superimposed. So I found another couple of animations just to kind of show you. So let me orient you a little bit. So the green wave you can see is stationary. It's not moving, but the blue wave is. And so that what we're meaning to show you here by the black wave is what the sum of the two waves at any one point in time will be. So when I see the blue wave and the green wave completely on top of each other as they are right now, then their combined height will be twice the height of the individual waves. Whereas when I see that they are opposite one another, in other words, where crest meets trough, then because they seem to have the same amplitude and period, they are canceling each other out completely, and the black line seems to sort of flatten out. So here we see two waves. It looks like they have a similar period. And so we can see when they start to combine how the crests and crests seem to combine, but then there are these moments where things seem to sort of stand still, and that's where we're seeing complete destructive interference. We're going to learn a little bit more about that later. And so I've switched to my Jamboard here because I want to show you how you might go about showing the interference of waves when they are superimposed. And so again, remember that the principle of superposition means that we're going to look at the algebraic sum of the two waves. And so let me draw these out. So when I look at this, I'm going to kind of try to recreate this wave and then this wave, but sort of on top of each other. Okay, and so to do that, I need to kind of look at, the basic dimensions of each wave. And so I've got 2 blocks up and 4 blocks over. So let me draw that. So I'm going to start over here. Here's just the wave, and then I'm going to go 2 blocks up and then 4 blocks over, and then 2 blocks down and over. Now, luckily for me, when I center them, they seem to have the same width. There's 1, 2, 3, 4 over. And so I'm going to do, because I don't want to show these in the same color, I'm going to do the second wave in blue. And so it looks like at this point I have 2 blocks down, and then over here I have nothing. So let me see. I'm going to go 2 blocks down, and then here I have nothing. So here I go. And there are the 2 waves on top of each other. So now, how do I show what they will combine to do? I'm going to do that just below. And so I have my wave going here. And I can see that in this case, and again, my diagram's not perfect, but it looks to me like I have 2 up and 2 down at this particular juncture right here. And so I'm going to mark that as just a nothing, right? +2 and -2, right? They're in opposite direction but equal magnitude. And so I'm going to use another point, which is right here. And so I can see that at this juncture, I have 2 up and then nothing down. So I'm going to just write that for emphasis, 0 down, right? So the algebraic sum, and let me write minus over here. So 2 minus 0, or 2 plus 0, will give me 2. So I'm going to go in the same spot, but up 2. Right here. So there's that line. Let me just make that a little nicer. There we go. Not really that much nicer, but whatever. Right? And so then I can choose to take spots anywhere along here that will work. I'm actually going to use my original drawing here. 1, 2, 3, 4, where I can see that at this spot right here, mine isn't that perfect, right? At this spot right here, I will have gone 1 down. So that should really be like right here. 1 down and 2 up. And so if I go up 2 and down 1, that means I am at 1. So 2 over, I'm at, oopsies, wrong spot, right over here. I'm at 1. So that helps me to construct what the 2 waves are going to look like when they're interfering, when they're superimposed.
So there should be a worksheet for you to work on that will be supplied for you, and it's a hard copy, so you can just do it by hand, and then we can revisit in class the next day and chat about any issues or struggles or if some clarification that needs to happen. And I'll see you then.